Okay, number 22. Same deal, this is a proper fraction, and what we are looking at, and again here I'm going to give it a lot of space, that is really 3t squared plus t plus 4 divided by, if I factor a t, that's t into t squared minus 1, so that's t into t minus 1 into t plus 1, basically a over t, b over t minus 1, c over t plus 1. If I clear the fractions, find the LCD and all, t minus 1 plus 1 is t squared minus 1, bt into t plus 1, ct into t minus 1. And if I let x equal 0 for starters, left side will be a 4, that will be negative a, and do you see that's a 0 and that's a 0, so I got a is negative 4. That's simple. If I let x equal, what's the next one, 1 in there, that's 3 plus 1, 4, 4 plus 4 is 8, a 1 in there will make a 0, a 1 in there and a 1 in there will make that b times 1 plus 1, which is 2, and a 1 in there will make that 0, that means b is also a 4. If I let x equal negative 1, I'm sorry, I'm so stuck on x, I mean t, right? You know what I mean. We forgive each other as long as you're not taking a test. A negative 1, that's a 3 minus 1, that is 2 plus 4, that's 6, that's a 0. Negative 1 right there, that's a 0. C times negative 1 times negative 2, that means C is 3. And that's really how complex the problems are. So I could say this integral right here would be the integral of, from 1 to radical 3, of negative 4 over t plus b over t minus 1 plus 3 over t plus 1. Now I'm not sure why I put the limits, but I put the wrong limits. I'm going to make that a 2 to radical 3, because otherwise that's the next section. And that's going to be negative 4 natural log of t plus b natural log of t minus 1 plus 3 natural log of t plus 1, right? And I'm going to evaluate that from 2 to radical 3. That would be negative 4 natural log of radical 3 plus, oops, did I write b? You know what I meant. What was b? B was 4. A 4 natural log of radical 3 minus 1 plus 3 natural log of radical 3 plus 1 minus, if you put the 2 in, that is a negative 4 natural log of 2 plus 4 natural log of 1 plus 3 natural log of 3. And again, on the homework or the exam, on the homework I suggest you work it out to see the answer and match it at the back of the book. For the exam, just leave it like that. Keep in mind, natural log of 1 is 0, so you could simplify this very quickly. And now let me look at another type of problems, slightly different. If I look at this again, the problem comes up to be, well, t squared plus 3t divided by, wouldn't this be t squared minus 4 into t squared plus 1? So wouldn't you say this is a over t minus 2, b over t plus 2, and t squared plus 1, isn't that not reducible over r, which means this is going to be c t plus d. We're going to proceed identically, clear the fractions like we did on every problem. A into t plus 2 into t squared plus 1, b into t minus 2 into t squared plus 1, ct plus d times t squared minus 4. If I let t equal a 2, I'll get 4 plus 6, that's a 10. A 2 in there and a 2 in there, that's a into 4 2, 4 into 5. So this is a 0 and this is a 0, which means A equals 21/2. Got A. Very good. If I let T equal a -2, I'll be looking at 4 minus 6, that's a -2. A -2 there, that's a 0. A -2 there, that's a 0. This is the only piece that will remain. That will be B times -2 minus 2 is -4 times 5, which indicates B equals a positive 1/10. But now I run out of numbers to do. Well, this is an equation, and I know this is 1/10. Guess what? I could let x equal 0 and 1. Any two values will do. Not x. Let t equal 0, for example. If I put 0, well, that's a 0. That will be 1/2. A 2 times a 1. A 0 there, that will be 1/10. -2 times 1. A 0 there, that's gone. I got d times -4. And here's d. So this is 0 equal 1 minus 1/5 minus 4d, or 0 equal 5 minus 1 minus 20d. So this is a 4. -4 equal -20d. So d is actually 1/5. And the last, I could let t equal 1. I'll get 1 plus 3 is a 4. 1/2, a 1 in each of those parentheses. That's a 3 times 2 plus 1/10, a -1 times 2. And for the last piece, I'll get c times 1 plus 1/5, and a 1 in there will get me a -3. So 4 equals 3 minus 1/5 minus 3c minus 3/5, right? So I could say, what is that? 5? No. I could say 1 -4/5 plus 4/5 equal -3c. So I could say 5 9/5 equal -3c. And if I'm not mistaken, I could say c equal -3/5. Okay, so this is actually the integral. Now, I could take a 1/10 out to make all of these constants. That makes life easier a bit. Or I could break, it doesn't really matter. I could say, you know what, that is the integral, 1/2 the integral of dt over t minus 2, that's not a problem. Plus 1/10 over t plus 2, plus a -3/5 plus 1/5 over t squared plus 1 dt. Now, this is 1/2 natural log of t minus 2. That's easy. This is 1/10 natural log of t plus 2. That's easy. Now, the problem comes up with those. I need to split this up. I need to take this and break it into two pieces. I'm going to say that is -3/5 the integral of t over t squared plus 1 dt plus 1/5 the integral of dt over t squared plus 1. So this will be 1/2 natural log of t minus 2 plus 1/10 natural log of t plus 2 minus 3/5. If you let u equal t squared plus 1, isn't du 2d dt? So that will be times 1/2 natural log of t squared plus 1. This, one of those integrals that I need to memorize. That's the inverse tangent of t plus c. I know you think this is a hard problem. This is a basic problem, something that comes up a lot on the long run. being long doesn't make it hard. Just you gotta work patiently and slowly. And on number 34, I notice this is an improper fraction. Before I proceed, partial fractions doesn't work most of the time. So what you have to do, you have to take x cubed divided by x squared minus 4. That's x. So you would say this is the integral of x plus 4x over x minus 2 into x plus 2. Actually, it's a lot nicer than I thought. Minus a plus 4x over x squared minus 4 dx. That is x squared over 2 plus, if I let u equal x squared minus 4, wouldn't du be 2x dx? So this will be, for the integral, so if I let this be u, that will be a u, and over 2 du, so that would be x squared over 2 plus, not 1/2, twice natural log of u plus c. And what was u? U was x squared minus 4. Here's another one. Again, it's an improper fraction. I'm going to try and figure out where this came from. And I am going to shrink this just a bit. Okay, if I take x to the 4th divided by x cubed minus x squared plus 4x minus 4, that will be x cubed, x to the 4th minus x cubed plus 4x squared minus 4x. And if I subtract, that would be x cubed minus 4x squared plus 4x. Let me just see what went wrong. Okay. And that would be x minus, now this will be x cubed minus 4x squared plus 4x divided by, if I take x squared out, that's x. So that is x minus 1 into x squared plus 4. Okay. A bit tougher than usual, but that's okay. And that's what I'm looking at. And the question now is, why do I always say minus? It's a plus. So I want to figure out where did... Oh, okay, I see why. See, I noticed something was not right. I couldn't figure out what. This is still improper. That's why it's not working. X cubed divided by x cubed is a 1. That will be x cubed minus x squared plus 4x minus 4. And if you subtract, wow, I kept on thinking, what is wrong? That will be negative 3x squared minus 3x plus 4. Much better. So this is the integral of x plus 1 plus a negative 3x squared minus 3x plus 4 over x minus 1 into x squared plus 1. And again, the same deal. All of this, of course, dx. So if I take negative 3x squared minus 3x plus 4 over x minus 1 into x squared plus 1, the least amount of work I could do is this much. I'm going to say this is a and this is bx plus c. Clear the fractions. I could use the book's method in this case. I could use our method, whatever you like. If I let x equal 1, I'll get negative 3 minus 3, that's negative 6, plus 4, negative 2, a 1 in there, that's a times 2, a 1 in there, that's a 0, I get a to be negative 1. Do you see, even if you decided to use the Book's method by finding a first, it'll make your life a lot easier, but let x equal 0. Since 0 is not in the domain, that will make this a 4. And remember, this is negative 1, so that's negative 1 times 1. A 0 in there will leave you a c and a negative 1. That means 5 equal negative c, or c equal negative 5. And now one more value, let x equal negative 1, 2, whatever you want. If I go for negative 1, I'll get a negative 3 plus 3, that's a 0, that's a 4 equaling a negative 1 there, that's negative 1 times 2, a negative 1 there, that will be negative b minus 5, and a negative 1 there will make that a negative 2, and guess what? I'm done. That's it. That is that is 4 equaling negative 2 plus 2b plus 10, so that is 8. Negative 4 equal 2b, so b is negative 2. Again, the algebra stands in the way. You must be able to get those, otherwise you can't do the problem. Now once you get those, you'll notice this is x squared over 2 plus x plus, you're trying to integrate a negative 1 over x plus 1 minus 2x plus 5 all over x squared plus 1 dx, and you always have to split that up. So that is x squared over 2 plus x minus natural log of x plus 1. And the last piece, if I take the negative, no, I need to split them up, plus the integral of negative 2x over x squared plus 1 here. Plenty of space, right? Dx minus the integral of 5 over x squared plus 1 dx. So this is x squared over 2 plus x minus natural log of x plus 1. This is minus natural log of x squared plus 1. Use a u sub. This is my 5 times inverse tangent of x plus c. Again, lengthy problems, not very hard, kind of long, you just gotta bear with it. And now that you know about this, this is gonna be coming up all over the next sections. I still have a couple of problems I want to tackle. One of them is number 40, prime. Whoa, what just happened? Okay, well here I notice a lot of e's. If I let u equal e to the y, du is e to the y dy. Well, let's see how this works. I could factor an e to the u to the y out. Again, remember, this is how I start thinking of these problems. I start thinking in terms of du. So if I take e to the y dy, factor an e to the y, that's e to the 3y plus 2e to the y minus 1 over e to the 2y plus 1. This is my du. And if I put wouldn't that be the integral of u cubed plus 2u minus 1 over u squared plus 1? Du. Okay, well now what? Now I need to figure out where this came from. Long division. if I take u cubed plus 2u minus 1 into u squared plus 1, that would be a u cubed plus u cubed plus u, subtract. This would be the integral of u plus u minus 1 over u squared plus 1 du. This would be the integral of u plus, you should always practice to split this. This is u squared over 2. This is 1/2 natural log of u squared plus 1. Let u equal this. And this is inverse tangent of u plus c. And what was u? E to the x, plug it in. That's e to the y. E to the 2y over 2 plus 1/2 natural log of e to the 2y plus 1 minus inverse tangent of e to the y plus c. There. So since this was an improper fraction, I didn't need to do much work. And I want to do one more problem before I conclude this section. So I'm leaving nothing out. I want to make sure I touch on everything we come across. And there's that problem. And I glance at this and I notice if this is going to be my du, then obviously I want u to be the sine, because derivative of sine is the cosine. Du is the cosine of u, cosine of x dx. I've been doing this for too long, forgive me. So this is du, and if I put a u right there, that will be u squared minus 2u minus 3. So I want to figure out 1 over u minus 3 into u plus 1 comes from which fraction? Well, to us in general this is going to be very quick, because when you do tons of problems like I'm giving you for homework, you'll become very efficient at this. Let u equal 3, 1 equal a times 4 plus 0, so a is 1/4. 95% of the time this is what we need. Let u equal -1, 1 equal, that's a 0, that's b times -4, so b is -1/4. So if I take 1/4 out, 1 over u minus 3 minus 1 over u plus 1 du, that would be 1 over 4 times natural log of u minus 3 minus natural log of u plus 1 plus c. And what was u? And of course, this is something that I normally don't do, but you could do. You could say that's 1/4, 2 logs with a minus. The back of the book might write this as, you don't have to do that, of course, if you wish. Either of those will, oh, hey, the wrong format. Here we go. And let me give you the homework. And there's our homework.